Minikits have been a staple of LEGO games since 2005. Exploring the brick-filled worlds, you may occasionally stumble across one of these iconic canisters, tucked in a corner or down some secret path. If you were to build a Minikit out of actual LEGO, it would be about the size of a 30-sided die. That's too small. So I scaled it up 10 times that size, and if that weren't enough, it also lights up. This video will be broken into 3 parts: the design and printing, the light wiring, and the programming. Each part will also have a separate, longer video going into more detail if you just can't get enough Minikit content. Without further ado, let's get started. Modeling LEGO pieces is surprisingly easy as they're fairly simple shapes. After squeezing a few bricks with some calipers, we have the exact dimensions of LEGO bricks and can start building a model. We start by making a rectangle, we then extrude that up, put a cylinder on top, duplicate that a few times, and we're making LEGO. Let's take a step back here and look at how to actually build a Minikit. A Minikit is made up of 11 pieces. 12 pieces. 4 white pieces making up the cylindrical body, 4 gray pieces splitting the body into 3 sections, 2 studs, and a 2-part lever. Using our numbers measured earlier, modeling out these pieces is fairly quick. But we're not just modeling a regular LEGO Minikit. Our Minikit will eventually need some internal electronics to light it up, so we need to design internal components into the pieces to fit a Raspberry Pi and the pathways for the wiring. One quick concept sketch and fitting, and we are good to go. With the model complete, we can move on to printing. Well, almost. These parts will take several hours to print and use up a lot of plastic. If something in the model is even a tiny bit off, we'll waste a lot of time and a lot of plastic. So we're going to isolate some of the tricky areas, print those, and do some quick test fits before moving to the full pieces. And now, we can start printing. Times is the perfect scale to allow each print to fit perfectly on my printer, with the largest pieces taking about 10 hours each. There were some snags in the middle due to some loose belts, but after a bit of maintenance, the pieces were coming out great again. Surprisingly, one of the trickiest pieces to print were the clear studs. Any little imperfection in the print wouldn't be hidden like it would on a less transparent piece. Just like that, we have a completed Minikit, but this Minikit needs RGB. Remember all those channels we modeled earlier? Time to put them to good use. For lighting, I'll be using WS2812B addressable RGB strips. Each of these strips has 3 connection points: a 5-volt power, a ground, and a single data line. By passing this data signal from one LED to the next, we can tell an entire strip what each individual light does. We're going to break the Minikit into 5 zones. We're going to have the upper zone on top, we're going to have the upper stud, the middle zone, the lower stud, and the base. The best way to do wiring is to have 3 branches coming off the Pi. One of them is going to go straight down to zone 5, one of them is going to go straight over to zone 4, and the last one is going to go up into zone 3, which is then going to go into zone 1, which is then going to go into zone 2. All of those are going to be in one big link. Using this nifty little block I printed a while back, we can line up our LEDs and wires and quickly drop down some solder on all 3. Then just repeat for the rest. All of this will be powered by Raspberry Pi 4, getting its power from a USB-C plug exposed on the back. Power from here will break out into each light strip and the Pi itself. Now for the last wiring hurdle. Being LEGO, we want to be able to connect and disconnect the pieces. So we need some way to connect and sever the wiring connections. Fortunately, the internet has a solution: JST SM connectors. Just take each wire end, snap on one of these metal bits, slide them into the black box, and bang! You got detachable and retachable wires. If only it were that easy. In reality, these are a pain to work with. The crimping is never perfect, and unless it is perfect, it won't fit in that special black box. Lucky for you, I edited out all the struggling. So how do we get the lights to turn on? And more importantly, control them in a way that looks cool. Let's deviate for a bit to mention why this project came up in the first place. It's not just my genuine appreciation for the best reoccurring in-game collectible, but for an event run by a friend, LEGO Jedi, called Minikit Marathon. The idea is when someone donates to the charity, the Minikit can flash fun colors. Wow. With that said, we need to write a program that can run lighting patterns based off some mysterious external force. So, break it down to the very basic level. We have 5 sections we need to control. So let's start there. I've broken it down to 4 modes that an individual zone could be. It could be a solid color. It could pulse a color, kind of like it's doing now, where it'll fade in and out between 2 colors. It could flash a color, where it'll go between 2 colors faster, or it can be random. So we have light zones now. We have this object we're calling a light zone. Specifically, we're going to have 5 of them. Now we need something that actually works with the lights. The light zones just determine the color. We actually need a light controller, which will communicate all those colors to their respective places. On the Raspberry Pi, we have 2 light strips coming out. We have the strip going to the uppers. We have the strip going to the lowers. The light controller is going to be responsible for managing these 2 strands. On those strands, we have the different lighting zones. So for the upper strand, the first 9 are going to be the middle section. The next 4 are the top, and the last 3 are the stud. The lower strand is much shorter, where the first 4 are the bottom, and the next 3 are the stud. And then we do a bunch of programming in Python, but I don't want to bore you with that. Moment of truth. Success. Time to message LEGO Jedi and tell them, I forgot about a stand. Now we are done. I'm really happy with how this turned out, and I think it'll be a great addition to Minikit Marathon. This was also my first project where I recorded the process and made a video about it. And I think I still have a lot to learn on that front. So if you have any thoughts on the quality or format of the video, please let me know in the comments down below. And if you're looking for longer format, more detailed videos of this project, I'll have those linked in the description. Thanks for watching until the end of the video. This is my first on the channel, and I have a lot more projects coming up, so subscribe if you're interested. Until then, play games, explore the world, keep making, and I'll see you next time.